Today we're going to continue working with higher roots. This time we'll be adding and subtracting them. Now again, it's not different than square roots, nothing is, as long as it's the same kind of root, cube root, square root, fourth root, whatever, and the radicands are the same, then you're just combining like terms. In our first problem we have the cube root of 4x plus the cube root of 4x, and that altogether would be 2 cube roots of 4x. In the second problem we have 4 fourth roots of 8 minus 2 fourth roots of 8. Since these are like terms, 4 minus 2 would be 2 fourth roots of 8. Finally, in the last problem we have a fifth root of 3x plus 3 fifth roots of 3x. Altogether that's 4 fifth roots of 3x. So as long as it's the same radical, we're just combining like terms. Well, what happens if it's not? Well, here are two problems where they don't start off the same, so we can't add or subtract these. But what we can do is simplify each of these cube roots, or at least try to. Now 54 is 27 times 2, and 27 is important because it's a perfect cube. 16 is 8 times 2, and that's important because 8 is a perfect cube. Our first one simplifies into 3 from the cube root of 27 times the cube root of 2 minus, well, the cube root of 8 is 2, so it would be 2 cube root of the 2 that's still left. And now that they're like terms, when we subtract these, all we get is 1 cube root of 2 when we're done. The second problem is similar. These aren't like terms, so we can't add them, but we could simplify. Our perfect fourths really matter. And with 48, we've got to see that this is the same thing as 16 times 3. And 243 is the same thing as 81 times 3. And both 16 and 81 are perfect fourths. The fourth root of 16 is 2, so this is 2 fourth roots of 3. The fourth root of 81 is 3, so this is 3 fourth roots of 3. And when we add these all together, we have 5 fourth roots of 3. So sometimes all you need to do is simplify first. Here's a problem where they're not like terms and there happen to be variables. The cube root of 24x to the 4th minus the cube root of negative 81x to the 7th. Can't subtract them, but we can try and simplify. Remember that 8 times 3 is 24, and 8's a perfect cube. And 81 is negative 27 times 3. And these will both simplify. The cube root of 8 is 2, so this is 2 with the 3 staying inside. By the Orndorff rule, 3 goes into 4 once, so it would be x to the first on the outside with 1 left over, x to the first on the inside. The cube root of negative 27 is negative 3. Oops, let's save some space here. With 3 staying inside, 3 goes into 7 twice, so this will be x squared with 1 left over. So we have minus a negative 3x squared cube root of 3x. Minus a negative means that we're adding these. Well, 2x plus 3x squared, you can't really do a whole lot with those. They're not the same. So the best we can do is show our intention to add those. 2x plus 3x squared times the cube root of 3x. Another way to think about it is we factored the cube root of 3x out of that expression. Why don't you try one of these? See what you can do with this last problem. Hit pause and give it a shot. Let's see how you did. We've got fourth roots, so we need perfect fourths. And 162 is 81 times 2, and 81 is a perfect fourth. 512 is also 256 times 2, and 256 is 4 to the 4th. So now we can begin to simplify these expressions. The fourth root of 81 is 3. And that'll leave us with 2 on the inside. 4 goes into y to the 9th twice, so it'd be y squared with 1 left over, so y on the inside. Fourth root of 256 is 4. That'll leave us with the 2 on the inside. And 4 goes into y to the 5th. Think about breaking this down once, so it'd be y to the 1st on the outside with y to the 1st left on the inside. These are now like terms, and the best we can do is write this as 3y squared plus 4y. We're adding the numbers on the outside times the fourth root of 2y. You could also think about it as we've just factored that out.